Okay, so in this problem, we're being asked to solve for the forces in each of these cables. This is a system of cables, and we have two critical points. We have point A and point B, which we're going to use to form our equilibrium equations and go from there. So we're going to start at point B, and I sort of drew the free body diagram underneath. And the reason why we're starting at point B is because we have an applied load here, and that is going to make our job a lot easier to solve our equations. So the first thing that we're going to do is we're going to find the magnitude of one of the cables. And just by looking at the geometry of the system, we know that cable BD, BC, AD, and AC are equal in length, and cable AE and AB are equal in length. So, as far as the length of cable BD, we can use Pythagorean theorem to solve for the magnitude. That is going to be 2 squared in the y direction, 2 squared, 2 meters in the x direction, and 4 meters in height in the z direction. And that is going to give us square root of 24. And we can use that in our equations now. So the equation in the x direction is going to be 2 over square root of 24. That is a fraction of force BD that is going in the x direction, minus 2 over square root of 24 FBC, and that is equal to 0. From this equation, we can see really quickly that force BD is equal to force BC, and that's going to be a helpful hint for later. Some of the forces in the y direction, we have 2 over square root of 24, and we're going to assume that this this force is in tension. We're always going to assume tension in these problems, which means that our force is going down like this, and so that is going to be a negative direction in the case of force BD. Same case with the force in BC. It's in the negative y direction, since we're assuming tension. And then lastly, we have force AB, and all of that is equal to 0. We continue with the force in the z direction, and we notice that we have a 2 kilonewton load going downwards, and so that is going to be a negative in our equation. Then we also have a negative 4 over square root of 24, and that is because it's going in the negative z direction in the case of BD and case of BC as well. And that is going to be equal to 0. Okay. And so at this point, we know that FBD and FBC are equal. And so we can go ahead and do a substitution. We can just substitute or leave this equation in terms of either one of them and solve for it, and then we'll find out the rest. So in this case, we can simplify this equation as minus 8 over square root of 24 FBC, and that's going to be equal to 2 kilonewtons. And so then that means, so FBC is going to be equal to square root of 24 over 4 minus sign in front, which is somewhere equal to negative 1.22 kilonewtons. And again, the negative just means it's pointing down as to what we define in our coordinate system. And we can go ahead and just write down our results. And we know again FBC is equal to FBD, so we solve for that one as well. Now solving for FBA, we can go back to the sum of the forces in the y direction, and we can simplify this equation. We can say that this is equal to minus 4 over square root of 24 FBD, and that's equal to FBA. And so plugging in our negative 1.22, we have that FBA is equal to 1 kilonewton. Now, we solve for all the forces that link up to point B, and now we can move on to point A, but with one assumption, and that assumption is that we know what FBA is, and by knowing what FBA is, we know the force in this cable. And again, we're always assuming tension. And so if we know that force, then we can use it to solve for the rest of our forces in the rest of the cables. So that's what we're going to do. So here we have a free body diagram of point A, and we're going to start by setting up our equations. So the sum of the forces in the x direction, we have force AD and force AC. So that's 2 over square root of 24. Again, just a fraction of the forces that are going in that direction. Force AD, and then force AC is going in the negative x direction. So in this case, again, force AD is equal to force AC. In the case of the sum of the forces in our y direction, now this is where we're gonna make use of force AB or force BA. So we have force BA plus 2 over square root of 24 FAD. And again, just emphasizing that because we're assuming tension, it's as though the cables were going in the positive y direction. So plus 2 over square root of 24 FAC, and this is equal to 0. And then lastly, setting up our equation in the z direction, we have minus 4 over square root of 24 FAD minus 4 over square root of 24 FAC minus FAE, and that's equal to 0. We're going to, similar to point B, we're going to make use of the fact that force AD and force AC are equivalent, and we can simplify our last equation a little bit more. We know this is equal to minus 8 over square root of 24 using just force AD. This is equal to force AE. Similarly, we have, let's see what we have. So the sum of the forces in the y direction, we know what FBA is, and we can substitute either of these into our equation. And so we can say FAD and we can just sum these two. So that's 4 over square root of 24 FAD is equal to negative FBA. And so we can solve for FAD, and FAD is going to give us basically the same. Oops. Go back. Let's see. Right. And so because we know FAD is equal to FAC, we know, oh, and that's going to be in the negative direction, or say, yeah. Yeah. And so then FAC is going to be equal. And then lastly, we can solve for FAD. Now, FAE. Now that we know what FAD is, we can solve for that, and that is going to be equal to 2 kilonewtons. Once again, using the fact that we knew what we had just solved for FAD. And that is it for a problem.